Welcome to probability videos 10.4, 10.5, and 10.6, probability with dependent events or conditional probability. All right, so first let's define dependent events. The occurrence of one event affects the occurrence of the other. So for example, if I pick a card from a deck and don't replace it, that deck has been affected, it's dwindling. All right, so I've got a few examples. First example, example 4. A couple has 2 children, each of whom is equally likely to be a boy or a girl. All right, you are provided information that one child is a boy. What is the probability that the other child is a boy? The common mistake, anybody in the class would usually say 50%, and they would be wrong. Here's how you want to do the analysis. So let's make the sample space. Okay, so I'll call one the older child, one the younger child. If they're twins, one was born first, or whatever, just whoever you named first, if it's a tie. All right, so it could be boy, 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 girl, girl, boy, or girl, girl. Those are the 4 possibilities for having 2 children. However, that's not our sample space, because they said, we know that one child is a boy. So this could not happen. So that's not part of our sample space. This is. In these 3 occurrences, we could have the information that the one boy is somewhere. So now this is our sample space, and we want to find the probability that the other child is also a boy. So that would be boy, boy. So this would be the successful outcome right there. 1 out of 3 possibilities. And that's kind of how conditional probability works. Okay, let's do a couple other examples. Example 5. You randomly select 2 cards from a deck. What is the probability that the first card is the ace of clubs and the second card is black if we do it with replacement and then without replacement? With replacement, just you're independent, just multiply the probabilities. Without replacement, being careful. Okay, so with replacement, all right, so the probability of the ace of clubs and being black would be the probability of the ace of clubs times probability of being black. And then the ace of clubs, there's 1 of those, so 1 out of 52. So then I put that back in, shuffled. The probability of being black, there's 26 out of 52. And if you reduce that, you get 1 over 104. Okay, part B, without replacement. Okay, so this is how it works. So I'm going to say the first card being the ace of clubs on the very first pick, 1 out of 52. Now what I'm going to do is, when I do it without replacement, I say, throw that ace of clubs in the garbage. It's no longer there. Now for my second card that I pick, the deck has dwindled. The deck only has 51 cards in it. And I want to find the probability that the next card is black. Well, I threw away 1 black card. So there's no longer 26, there's 25. And if you compute that, you'd get 25 over 26, 52. So again, it's very important, this vocabulary, with replacement or without. All right, one more example, and this will just be set up only. You randomly select 5 cards without replacement. What is the probability of the following? And again, just set up the work. Ace of hearts, followed by king of diamonds, followed by a red card, followed by a black ace, followed by a black face card. And for this analysis, just assume we pick this, throw it in the garbage, and then deal with what's left. All right, ace of hearts. All right, I'm pretty sure there's only 1 of those. So that would be 1 over 52. Gonna multiply. King of diamonds. There's only 1 of those. However, I threw the ace of hearts in the garbage. So there's 1 king of diamonds out of 51 remaining cards. Red card. Okay. I can just do all the denominators. This would be out of 50. This would be out of 49. This would be out of 48. So to get partial credit, at least get the denominators correct. All right, a red card. This card was red, and this card was red. So there's 2 red cards in the garbage can. I had 26, take away 2, 24. Again, I'm not reducing this, I'm just showing you the setup. A black ace. I did not get rid of any black aces, so there's 2 black aces that remain. A black face card. I did not dispose of any black face cards, so I've got to find out who the black face cards are. All right, so jack, queen, king of clubs, and also of spades. So there's 6 black face cards. Again, we're not computing this. It would be a very, very small number. We're just setting it up. So there you have it. How to use probability with dependent events or conditional probability to solve problems with boys and girls and with cards.